So we've been through a couple different formulas for determinants so far. So far, you should have under your hat the 2 by 2 formula that we learned a long time ago. You should have the idea that if I get it to an LU decomposition, I can just multiply the pivots. And then you should have the big determinant formula in your head. Or at least you should have seen the big determinant formula. The cofactor formula is the one I'm going to use when I'm calculating determinants by hand. The cofactor formula is relatively straightforward to do. It does take a lot of like multiplication of little numbers, so it pays to be a little careful here. If you've taken a Calc 3 class and seen the cross product, you're a little bit of a step ahead here. So I'm going to show you how to do this by example first, and then I'm going to write down some more general stuff. So I've got here a 3 by 3 example, and I would like to calculate the determinant of my matrix A here. And the way I'm going to do this is that same thing we arrived at the end of the big formula. So I'm going to take A here, and then I'm going to multiply A by the determinant of the matrix that I get when I leave off the row and column that A are in. So that's going to be E, F, H, I. Then I'm going to subtract B, and here I'm going to leave off the row and column that B are in. So I'm going to get D and G, F and I. And then I'm going to add to this C times the little matrix that's left when I delete the row and column that C are in. So that's going to be D, E, G, H, right? And then I'm going to go through and calculate each of these determinants. So I'm going to say, all right, so that's A times EI minus HF. Then I'm going to be subtracting B times DI minus FG. Then I'm going to be adding C times DH minus GE. Done. Right? After multiplying those numbers together, that'll be my determinant. Now, there's a little bit of a trick to this. The trick to this is that you can pick any row or column that you want. The trouble is getting the signs correct, because you'll notice there's this minus sign that got attached to B. I figured out, I think, where that came from in the big formula. It just kind of appeared. It appeared because of the permutations. I'm just going to give you a way to figure out what it's going to be. So the way you're going to figure out what it's going to be is you're going to look at this matrix, right? And you're going to make a checkerboard. It's going to start with a positive in the top left corner, and then it's just going to be a checkerboard of positive negatives. So in my case, it's going to be positive, negative, positive, negative, positive, negative, and positive, negative, positive. So that's my little checkerboard of signs. Now, I'll note that A went with a positive sign, B went with a negative sign, and C went with a positive sign. That's all there is to this. So if you want to calculate this determinant a different way, right? So here's my other way to calculate the determinant. I'm just going to pick this. I'm just going to pick this third. What the hell? I'm going to pick this third column. Okay, so that third column is what I'm picking here, right? And so I'm going to look at the numbers in that column. They go plus, minus, plus, right? So I'm going to take C. So I'm going to say, all right, so the determinant of A is also C. C got a positive on it because it's this entry here. And then I need to delete the row and column that C are in. So that's going to be C times the determinant of D, E, G, H. And then I'm going to subtract F times the determinant, and I need to delete the row and column that F is in. So that's going to be A, B, G, H. And then I'm going to add, and I'm going to delete the row and column that I is in. So I'm going to get the determinant of A, B, D, E. Oops, I needed an I there. And if I multiply this crap out, I'm going to get the same crap that I had up here, right? So this is going to be C times DH minus EG minus F times AH minus GB, that's a B, plus I times AE minus BD. And you can convince yourself pretty quickly that these are the same. Like, okay, here's an IAE term, right? And then there's a minus BDI term. So that's this guy. And then you're like, okay, well, someplace here there's a minus HFA. Oops, there he is. Minus HFA. Then I'm like, all right, maybe there's should be a plus B, yep, plus BFG. Okay, yep, if I multiply the F in there, I got a plus BFG. Then I ought to have a CDH. CDH is right there. Then I also ought to have a CGE. Yep, CGE right there. So even though these were in a slightly different order, right, I got the same set of numbers. That's going to be true if you pick any row or column here to do this. The trick with calculating these is that it's easiest if you pick a specific row or column, right? So pick a row or column that's got a mess of zeros in it. It'll make your life a bit easier. Okay? So the trouble with the cofactor formula is that if I'm doing a 4x4 case, I have to first go through a 4 row. So let me write out a 4x4 matrix here, right? So let's say, all right, so I'm doing A is A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, right? And I'd like to calculate the determinant of this. So we're going to go determinant of A equals. And we're going to think about our little grid here. So I'm just going to pick this top row because that's what I do when things are like ambiguous, right? There's no zeros in here, so I'm just going to go ahead and pick that top row. And I'm just writing down the signs to remind myself. So then I'm going to do A, that's a plus, and then I'm going to have here times the determinant of FGH JKL NOP, right? That's what I get when I delete the row and column that A is in. Then I'm going to do minus B times the determinant of first column is going to be EIM because I'm deleting the row and column that B are in, right? I'm going to skip the column that B is in, and I'm going to get GKO and HLP for that third column. Then I'm going to add C times, and I need to delete the row and column that C are in. So I'm going to get EIM, FJN, and HLP. And then I'm going to subtract D, and here I'm going to get the matrix where I've deleted the row and column that D is in. So that's going to give me an EIM, an, oops, jumped the gun on the L, FLP, FLN, oh gosh, I can read, FJN, so that's this column here, and then a JKO, so GKO. And now I'm going to have to go through and do the determinant for each of these 3x3s. Pretty sure that's gross, but we could do it, right? This is just a matter of perseverance, essentially. This is why the computer doesn't do this formula, because it's real gross. So this formula grows as n factorial, and it's recursive. So this is not an algorithm to program into a computer. You'll just burn processor time for no reason. For computers, use that LU decomposition where we multiply the pivots, right? For by hand, I'm not going to ask you anything over a 4x4 unless it's got just an absolute mess of zeros in it. Okay, so I'm going to give you the general formula here. So the general formula is we take the determinant of A, And we take that by doing AI1 times CI1. So these C's, these dudes, are called the cofactors. So this is the I1 cofactor. And I'm running this determinant. I'm running the cofactor method, and I'm running this on row I. Right, so I just picked a row. You could pick a column too, it works just as well. So I've got AI1 cofactor CI1. Then I'm adding AI2 CI2. Then I'm adding AI3 CI3. And we're going to keep adding until we get to the end where we've got AIN CIN. And the trick with these guys is that each of these things, right? The cofactors are given by this. So the cofactor Cij is -1 to the I plus j. So that's where our plus minus sign is coming. This part's doing our checkerboarding. And then we're going to have times the determinant of Mij, where Mij is A, but with ith row and jth column deleted. Right? So that's the same thing that we've been doing up here, right? So this is the 1-1 cofactor, right? I remove row 1, column 1, I get this guy. Here, this is the C1, or sorry, M12 cofactor, right? So I've deleted the first row and the second column. Sorry, I said cofactor. This is just the matrix M. With this minus sign, then it's the cofactor. So the cofactor here is this guy, the determinant of this matrix. That's the M13 matrix. That's delete row 1 and column 3, right? You can see how this works. So should be noted that you can use this on columns as well. Should be noted that you ought to pick one where lots of stuff is 0. So let me do a real quick example. So here's a real quick example. I've got a matrix that's got, I don't know, some number x in these these positions, and then zeros otherwise. Now, I'm just going to go ahead and pick the first column here, and I'm just going to put my signs up here to remind myself. So that's going to be a plus, minus, plus. And I'm going to go, all right, so the determinant of this guy is going to be that first x, right, times the matrix that I get when I delete this row and column. So that's going to be determinant of 0x, 0x. And then we're going to do minus 0 times doesn't matter, plus 0 times doesn't matter. This is why you pick rows and columns with zeros, because you don't have to figure out what these submatrices are even. Right? It doesn't even matter what it is. It's got a determinant. When I multiply it by 0, I get 0 regardless. And then this guy, I end up with x times 0 minus 0. That's 0, so I end up with a fatal 0 out of this. Hope that makes sense. Keep in mind, you really want to aim for that column or row of zeros. Makes your life way easier. Thanks, guys. Catch you on the next one.